The MCQ is related to the topic, the equilibrium constant Kc and Kp. Look, the graph shows the yield of a product in a gaseous equilibrium. So there's a temperature and the percentage. If you see, when we are increasing a temperature, because this side we are increasing a temperature. So when we are increasing a temperature, what happened to the amount of a product or the yield? The yield is decreasing. So when increase in temperature reduce the yield, so what this give an indication? This give an indication that this is an exothermic reaction. Because in exothermic reaction, increase in temperature shift the equilibrium toward the left hand side or reduces the yield or amount of a product. So it can be C or D. It can be A or C. Then what is the effect of the pressure? If you see the pressure, at 200 atmosphere, we get less product, but at 300 atmosphere, we got more product. And we know when we have a high pressure or when we increase the pressure, equilibrium shift towards side of less moles. So which side we have less moles? It means the number, we have the less moles in the product side, because if I have, let's say A and is reacting with B and it is forming a product C. So there are 2 moles of reactant and 1 mole of a product. So when I increase the pressure, at high pressure, the equilibrium shift toward the right hand side, or I will have more yield of a product or greater yield. So at 300, at 300 atm, this was the yield. At 200 atm, this is a yield. So this given indication, higher yield at high pressure means the equilibrium shift toward the right hand side, or less number of moles of a product. So the number of the moles of a gas is, or the product is decreasing. So C will be the right answer. Is it clear? In this question, consider the equilibrium. Which of the following is true when total pressure of the system is increased? First thing we know, there is no effect of the pressure on the value of a Kc or a Kp. So it will be unaltered, like no change. So either B can be an answer or D can be an answer. Then what happened to a mole fraction? Look, when we write the value for a mole fraction, like when we write Kp, Kp will be the product of product PCl5 divided by pressure of the chlorine and pressure of the PCl3. Okay. So you can see that this is 1 mole and this is 2 mole. So when I increase the pressure, the total pressure increase. So increase in the denominator will be more than increase in the numerator. So what happened to the mole fraction? The mole fraction, the total mole fraction will decrease because denominator is more than the, but they are not asking like the mole fraction of overall, they're only asking for a mole fraction of PCl5. So when we increase the pressure, the mole fraction will also increase. Because, so mole fraction, why the mole fraction for this one is also increasing and mole fraction for this also increasing. But the overall mole fraction, if this was a question, if this was a question and they said only the mole fraction for the reaction, like no specific substance was there, then what will be the answer for a mole fraction? The mole fraction will decrease. But they specify a substance, they said the mole fraction for PCl5. So what will happen when we increase the pressure? The mole fraction for PCl5 is increasing. Even if it was written what happened to a mole fraction of a chlorine, that will also increase. What happened to mole fraction of PCl3? That will also increase. Because when you increase the pressure, the mole fraction will always increase. But for the reactant as well as the product. But what happened to the overall mole fraction depending on how many moles of reactant and product we have? If a reactant have more moles than the product, so that overall mole fraction will decrease. If a product has more moles than reactant, overall mole fraction will increase. And if they have the equal number, then the mole fraction won't change. So in this case, the correct answer is B. Is it clear? Kc and Kp is only affected by temperature. No other factor can affect the Kc or Kp. If the total mole fraction decreases, what do we do? Pressure to keep Kp remain constant. Look what happened here. The Kp won't change. Look, when I write the Kp will be the pressure of PCl5 divided by pressure of Cl2 times the pressure of PCl3, okay? When we change the total pressure, Kp won't change. So Kp, let's say Kp remain 10, okay? But what happened? This value increases when this value increase and this also increase. But the increase in the denominator is more than increase in the numerator. So what happened to overall mole fraction? The mole fraction will decrease. The total mole fraction. So total mole fraction will be 8, let's say. Now to balance that, it has to reach 10. So it has to reach 10. That's why the balance or equilibrium will shift towards the right hand side so that we'll get more product and less reactant to counter that. So the moment we apply a pressure, the total mole fraction of this reaction decreases. And to counter that, the equilibrium shift toward the right hand side. So we'll get more PCl5 and less amount of Cl2 and PCl3. Is it clear? The next question. What will be the equation for correct expression for Kp? Remember, it's a heterogeneous equilibrium. So we don't include solid, liquid, or we don't include them. We include only gaseous and aqueous in a heterogeneous equilibrium. And it is a Kp. So when it's a Kp, you just include the gases. So this is a solid, no need to include. So we have hydrogen, the product divided by reactant. So C will be the right answer here. Methane hydrate CH4.6H2O decomposes to form methane in water. And total enthalpy change is positive, means the reaction is endothermic. Which condition of temperature and pressure give the highest yield? Like which conditions will shift the equilibrium towards the right hand side? So when we check, this is an endothermic reaction. Endothermic reaction prefer a high temperature. So temperature must be high. Either A can be an answer, B. What about pressure? Here we have 0 moles of the gas, like this solid. Here this is a liquid, so 0, and gas is there 1. So what will happen if I want more methane? So it's a more moles on the right hand side. So if I reduce the pressure, equilibrium shift towards side of more moles. So I should use a low pressure and high temperature to get more methane. Because when we talk about the moles of the gas, we don't include solid, the liquid, we only include the gases. Question 15. In question 15, the equation for a decomposition of a hydrogen iodide, the reaction is endothermic. What is the effect of raising a pressure on the reaction mixture, on the reaction rate, like speed, equilibrium, yield, and Kc? First thing, what happened to a Kc? Kc is not affected by pressure, so it will be no change. So either A can be an answer or C can be an answer. Then we are changing a pressure, but when we check the number of moles, 1 here and half plus half 1. So there is no effect of the pressure. So the pressure will not affect the Like it will not shift the equilibrium because we have equal number of moles. And what happened to rate? Rate of a reaction is directly proportional to temperature, pressure, catalyst, surface area, concentration. So the rate, as we are increasing at pressure, so the rate will also increase. Why the yield was not changing? Because the equilibrium was not shifting, as there were equal number of moles of the reactant and product, the gaseous moles of reactant product. For the first reaction, when we write Kc1, it is the product, the hydrogen, iodine divided by hydrogen iodide. When we write Kc2, hydrogen iodine divided by hydrogen iodide square. We want a relation first. As you can see, this is delta H1 and this is delta H2. So here we have 1 mole and here we have 2 moles. Or here like 1 mole of hydrogen iodide and here we have 2 moles of hydrogen iodide. Or we have half moles are there and we have 1 moles. So what will happen as the number of the moles are double? So we can say that delta H2 will be equals to delta H1 multiplied by 2 because twice. So the enthalpy change is delta H2 is equals to delta H1 twice. Like because the delta H2 has 2 moles and this has 1 mole. So, or I can say delta H2 divided by 2 will be equals to delta H1. So either B can be an answer or D can be an answer. And then what about when we compare these two equations, Kc1, if I square this equation both sides, or if I, because this is the, we want to make a right hand side same. So if I take a root for this equation both sides, so then the left hand side is equals to right hand side. So Kc1 will be equals to under root Kc2. So it will match with option D. Because why did not square the first one? Because the expressions are given Kc1 is equals to Kc2. So Kc2 we have to change. We have to make the right hand side equal. Then we compare the left hand side.